The AWS well-architected framework is a six-pillar design principle set for cloud-based IT systems. And these design principles are all about making sure that the use of AWS cloud services is done in the correct manner, that it's matched against the appropriate business needs and used as efficiently and effectively as possible. Now, those six pillars are operational excellence, security, reliability, performance efficiency, cost optimization, and lastly, sustainability. So these are the six pillars of the AWS well-architected framework. Let's dive into each of these in further detail, beginning with operational excellence. This is all about monitoring your deployed AWS services to ensure peak efficiency and utilization. Now, we can do this by viewing performance metrics through CloudWatch. And of course, this is related to continuous improvement of those systems. Now, this could mean that we have CloudWatch alarm notifications that let us know when things get to a certain point, such as CPU utilization exceeding a given percentage or having less than a desired amount of memory available for an application. It also means that we have to establish a baseline of normal activity for a given deployed service. So defining a standard baseline so that we can easily identify when there are anomalies in terms of performance. The security pillar, of course, deals with things like data confidentiality, making sure that only the authorized services or users have access to data they should be able to have access to. This really means encryption both over the network as well as for data at rest. And of course, if we think about things like S3 buckets, they are encrypted by default using Amazon server-side keys. Data integrity means we need a way to assure the authenticity of data and that it's not been tampered with. And one way that can be done is using CloudTrail auditing to track access to sensitive data that perhaps might have been classified using Amazon Macie. Security also deals with identity and access management, or IAM, user accounts, groups, roles that could be assigned to software entities so they have the appropriate permissions to access AWS resources, policies which define the permissions, threat detection solutions, and so on. So it's all about protecting information and the systems that use and generate that information. The next AWS well-architected framework pillar is reliability. One of the options we have in AWS is to distribute our services in terms of their design, such as across regions. If there's a regional outage for some reason, a disruption, we might have something like an S3 bucket that's been replicated to an alternate region. Or we might spread out a load balancer across availability zones or AZs so that we are at least resilient against a data center failure within that AZ. But this means that an organization needs to have carefully crafted disaster recovery plans, or DRPs, for each subsystem, such as for a customer-facing web app versus an internal line of business database perhaps used by employees. Each of those systems should have a different disaster recovery plan so that it's a proactive plan to quickly recover in the event of a disruption or an outage for that particular system. Reliability also means being able to change when needs change, such as scaling out, using auto-scaling to add EC2 instances in response to an increased workload for a given app, as one example. The next pillar is performance efficiency. Now, what's always important with this one is matching the appropriate service itself to a business need, because there are a lot of Amazon services available for AWS. You need to make sure you know which one best meets the business requirements and then sizing it according to the workload requirements. Sizing means that you allocate the resources that are required to make something run well. Maybe even a bit of buffer space to allocate a bit more horsepower to handle peaks in that demand. So you can monitor performance metrics. Again, you could use CloudWatch to do that, and then adjust the sizing accordingly over time. Now, when it comes to monitoring IT systems, it is normal to have certain peaks and valleys in utilization. Just because we have a spike in concurrent connections or CPU utilization for a given app doesn't necessarily mean we don't have enough horsepower. You need to monitor it over time to see what's normal versus what's not normal, and then determine if the app is performing well, such as are users happy with the performance if it's a user-facing type of app. We can also use dashboard visualizations to easily and quickly gain performance insights. The next pillar is cost optimization, such as removing unused resources. If you have deployed a test environment, maybe with EC2 instances or RDS databases, if you're not using them, remove them if you no longer need them, or at least shut them down. You're paying for everything while it's running by the second. So you want to be efficient in that way. There's also the option of using spot and reserved instances. A spot instance means you're using extra compute capacity available in a data center at that time, and it's not guaranteed, but you're getting it at a discount. Whereas reserved instance pricing means you have a 1-year commitment, perhaps longer, to use compute power at a discount. And that would be appropriate when you need 24/7 compute time. You might also consider the use of cost budget alerts. Part of cost optimization is monitoring your monthly spend, determining what an acceptable ceiling limit is where you should be notified that you're getting to that price point. Cost optimization also means monitoring usage and performance metrics. For example, if you have over-allocated resources to an extreme degree for an app or an EC2 instance, you might realize that it's only ever at 5% CPU utilization at the most, yet you've got it optimized to use 12 vCPUs. You're paying for that unnecessarily. So that's another part of cost optimization. The sixth and final pillar of a well-architected framework would be sustainability. And this is twofold. On the Amazon Web Services side, it means data centers that run efficiently, that use renewable water and power. But on the customer side, it also means that we need to make sure that we optimize our services to meet the demands of our workloads, and ideally not have way too much stuff running in the cloud that isn't needed. Because in the end, that's using energy. It's using electricity, which is not great for the environment. So use what is required to meet a given need. That's what sustainability is about.